Hello again, Math 104 Trig students. Taking a look at some stuff in chapter 5, maybe some hints that'll help some people out. But this chapter dealt with identities. And one of the big things with identities was to be able and prove another identity exists by using old identities. And one of the ones I want to point out is this one. This is actually the Pythagorean identity. And I'm pretty sure all of you are familiar with this sine squared plus cosine squared equals 1. But there's two more that go along with it, and I'm going to quickly derive them to help you out. And the next one's going to come from if I divide everything on both sides by sine squared. Here I'm going to have sine squared divided by sine squared. It's going to give me 1. Here I'll have cosine squared divided by sine squared. That's going to give me the cotangent squared. And then finally, 1 divided by sine squared would give me the cosecant squared. Repeating that process, I'm going to divide everything by the cosine squared. Sine squared divided by cosine squared gives me tangent squared, plus cosine squared divided by cosine squared is 1. And finally, 1 divided by cosine squared is secant squared. So whenever I get ready to do the identities, I know how to get the first one. I'm just familiar with it, but I can quickly come up with the next two just by dividing by the sine squared, or in the second one, dividing everything by the cosine squared. Some other identities that quickly come to mind for me is the sine of a sum is the sine of the first cosine of the second plus sine of the second cosine first. And if you're doing these and saying them after a while, you'll get them down to, they just roll right off your tongue. Now, I also know that S starts sine, so S is also for same. So this is plus, this is plus, this is minus, and this is minus. So when it comes to the cosine ones, I know the signs are the opposite. So when I have the cosine of the sum, it's a minus. When I have the cosine of a difference, it becomes the plus. As you can see in the cosine, it's cosine of the first, cosine of the second, minus sine of the first, sine of the second. So I start making a list of some of the identities that I know are most popular. Some strategies when I get ready to do these identities. One is, can I get away with converting everything to sine and cosine and work with it? I always keep that in mind. The next one is working with the largest side, or a side that I can quickly change into something. And you're going to see in this first example, I give you why I'm actually going to work with this side versus this side. Again, keep using identities. And then there's other strategies that as you go through, you'll start to pick up. So for this one, I'm going to start by working on the left side. And I know when you take your test and you're typing this in, you're going to have some difficulty, but do the best you can. So if I work with the left side, I'm going to use these sine of the sums and differences. So the sine of x plus y is going to give me the sine of the first times the cosine of the second, signs are the same, plus the sine of the second, cosine of the first, over, now I'm doing the cosine of a difference. That's going to become the cosine of the first, the cosine of the second. Sine changes to a plus, sine of the first, sine of the second. Okay, so I took something that looked a little simple, but it actually got a lot more complex. Now, the reason I did that is because I noticed over here I have one term plus a term plus a term. It's almost like a binomial over a binomial. And when I expanded this, I got the same type of layout. That's like when you get problems and you have a fraction on one side and a constant on the other. One of the first things you want to try to do is eliminate this fraction somehow. And when I do the second example, you're going to see what I'm talking about. Okay, coming back up to this. Now, this guy would be great if it was 1. And how would I make that 1? Well, I would divide him by cosine x cosine y. Well, if I divide him by cosine x cosine y, I have to divide everything. And when I start doing that, I say, okay, cosine x cosine y, cosine x, cosine, and I can keep going through dividing everything. And what I'm quickly going to get is something that looks like this. So if I divide by cosine x, cosine y, I'm going to get sine of x, cosine of y, divided by cosine of x, cosine of y, plus, here I have sine of y, cosine of x, divided by the same thing, cosine of x, cosine of y, over, and for this one, I'm going to take cosine of x, cosine of y, and divide it by cosine x, cosine y, plus this guy, sine of x, sine of y, divided by cosine x, cosine y. And what do I end up with? Cosine, sine of x over cosine of x equals the tangent of x. Plus, if I take a look at this one, I get sine of y, cosine of y, which gives me the tangent of y. Over, if I take a look at this guy, I get my 1. And if I take a look at this guy, I'm going to get tangent of x, tangent of y. Now I come back up here and I say, oh, this was really close. I almost got what I wanted. So where did I mess up? I think I copied the problem down wrong. This guy should have been what you see down here. Instead of cotangents, they should have been the tangent of x plus the tangent of y over 1 plus tangent of x, tangent of y. Okay, my apologies for that. I could have gotten to this step. I would have again had to divide each of the terms to get where I wanted, but we're going to go with this. So we proved the identity we were looking for. Sorry for the confusion. Let's take a look at the second example. This time I'm going to take a look at the sine of theta. I'm trying to make this so you can see. Sine of theta plus tangent of theta over 1 plus the cosine of theta equals the tangent of theta. Now, when I look at this, this was what I was talking about just a little bit ago. I have the fraction on the left and a single term on the right. This is my bigger side, so I'm going to work with this. One of the tricks you should have seen for fractions is to take a look at the denominator, and when I see something that looks like 1 plus the cosine of theta, my first instinct is I'm going to change that by multiplying by its conjugate. Its conjugate for 1 plus the cosine of theta is 1 minus the cosine of theta. When I multiply top and bottom by 1 minus the cosine of theta, all that is multiplying by 1. So now I'm going to distribute. Double distribute up top. Sine of theta times 1 is sine of theta minus sine of theta cosine of theta plus tangent of theta times 1 is tangent of theta minus cosecant of theta tangent of theta. Hope I'm getting somewhere. These guys, this is the product of a sum and a difference. It's going to leave me with 1 minus the cosine squared of theta. And already I know that 1 minus the cosine squared of theta is going to come back to here. 1 minus the cosine squared of theta is the sine squared. So my denominator now is going to become the sine squared. In the numerator, I have the sine of theta minus sine of theta cosine of theta plus tangent of theta minus, okay, so the cosecant is the same as 1 over the sine. The tangent is the same as sine over cosine. So I have 1 over sine and sine over cosine. They cancel out. And what is it I'm left with? 1 over the cosine. My mistake. This is the cosine. Sorry about that, folks. This is the cosine. No wonder it wasn't working out for me. So what am I going to get here? I have the cosine of theta times the tangent of theta. The cosine times sine over cosine. It's going to cross out the cosines and leave me with just a sine in that term. Sine of theta minus this cosine, negative sine of theta, cosine of theta, plus tangent of theta over sine squared. Tangent is the same as sine over cosine. So now what I'm going to do in my numerator is I'm going to pull out a sine of theta. I'm left with negative cosine of theta plus, if I pull the sine out, 1 over the cosine of theta over sine squared of theta. So little tricks. We're using a lot of little tricks to do this one. I'm going to cancel a sine squared out. So now I'm left with negative cosine of theta plus 1 over the cosine of theta over, when I cancel it, I'm left with just a sine of theta. Combining these two, I'm going to multiply both of them by cosine to combine them. Common denominator would be cosine, so I'm going to get negative cosine squared of theta plus 1 over the cosine of theta. All of that is over the sine of theta. 1 minus cosine squared, again, we said is the sine squared of theta. And to divide by sine of theta is the same as multiplying by the reciprocal. If I cancel a sine of theta and a sine of theta, I'm left with sine of theta over cosine theta, which gives me tangent. Okay, that was a lot, especially when you make an error like I did up above, and I do apologize. I don't know why I wrote cosecant. Got a little excited there. But hopefully that helps, and that's one of the things from chapter 5, a video, and hope it helps for the test. Good luck.